All right, guys. My name is Pratik. I'm going to be the instructor for today's session, guys. I hope everybody can see me properly without any problem. Yeah. All right. Thank you, guys. Okay. Thank you for participating in the quiz, guys. You can see your results. What is the full form SQL? Everybody was correct. Structured query language. Which command helps us to read the data from a table? Okay, select 11 people participated, and that's correct. How many primary key a table can have? One, more than one. Okay, so answer is one. The other primary key columns can be called as candidate key. Which of the following SQL statement is correct? Select username and password from users. No, that's incorrect. Select username, comma, password from user is the correct answer. The third and the fourth are wrong. What are the data types that are not supported in SQL? Boolean is supported, numeric is supported, text is not supported in SQL. And images are also not supported in SQL. So thank you for participating in this fun basic quiz, guys. Now let's get started with the content. So guys, I've spent 17 years in the data consulting industry, and education wise, I'm a computer engineer. However, SQL is one of my first love, if I may say so. And so today, that is what we will discuss. And before we start discussing with SQL, let me give you a fun fact about SQL. SQL is one of the top three skills in the world for any data science person to learn. Okay. Now, traditionally, when I started learning SQL, when we started working on SQL back in late 90s, then we used to write SQL queries on on-premise servers. On-premise servers is that means local servers. Okay. But these days, we don't write normally SQL on on-premise servers, but we work on databases which are on the cloud. Okay, so I have used a few words here, including what SQL is, including database, cloud, and so forth. So we'll talk about that also, and we'll also talk about how SQL helps us to work with the amount of data that we have. So, for example, let me pull some data from Excel. Okay. Now, since the focus today is to learn and analyze or manipulate data on on a CAP aggregator data, so I picked up one of the live case study. I picked up a case study which has real data from Ola. Okay. Now, if you look at this particular table, and if you look at the header of this table, we've got columns like let's see, let me expand it a little bit. So we got columns like pickup date, pickup time, pickup area, because of course, when a cab driver picks you up, then, he or she will pick you up from a specific area. And of course, we also have a drop area here. And then we have a unique booking ID for each one of the rides. Then we have a booking type meaning, whether this booking is at kilometer, which essentially means rental, 4 hour 40 kilometers also rental, and then P2P is point to point, RT is return, and so on and so forth, right? Booking mode online, or some other, on the phone, on the app, different booking type, and then driver number. So a distinct unique driver number is given to each driver, right? But remember, one driver can drive multiple times into one pickup area or one drop area. Service status, whether the service was cancelled or not cancelled. Then we have fare, the actual amount of money spent on a cab ride, and then the distance traveled, the date it was confirmed at. So these are the columns which are there in this data table, right? I'm sure everybody understands that columns are these vertical columns, right? And the column headers are these here on the top are also called as fields or attributes of this table, which essentially, even if I hide all the data, even if I hide all the data that are there in this table, you would still have the columns underneath, the headers for this data. So large data, so it's taking some time to select this data. Let's say I select this and I hide it, right? So if you notice, even if I hide the data, you can still understand what kind of data this table will contain. So the table will contain pickup date, pickup type, pickup area, drop area, booking ID, booking mode, booking type, driver, service status, fare, confirmed at. All these column headers can easily describe you what kind of data this table will contain, right? And that is why these column headers are also called as the features or the attributes of this table. Because just by looking at the column headers, we can know what kind of data the table will contain. So they're also called as fields, attributes, or headers of a table. Are we clear, guys? Now, these terms, why am I clarifying these terms? Because we'll use these terms quite often today. So everybody should be aware of these terms so that you don't get confused as to where and what we are doing and what I am referring to as a column or as a row. And what is a row? These are rows. Each row here, each horizontal row is called as a data set or a value set. So if you notice here, each row contains what, guys? What does each row contain? What do you guys think? What do you think each row contains what? The data, of course, the way it contains the data, Ramsey, it contains the data, but data about what? If I just look at one row here, suppose if I pick up this particular row, what is this row representing? In plain English statement, what is this representing? Muhammad Ali is saying knowledge, okay, Divya is saying data, observation. But in this case, each row here represents one cab ride data, complete data about a cab ride, right? Complete, Komal says, the data of cab and the driver. Okay, well, essentially, it contains the data about a ride, right? A transaction that happened when a customer took a ride in a Ola cab from point A, that means from pickup area to drop area, right? It contains all the data that we need, right? Now, that is that one data. Now, let me show you one more table that we will work with today to analyze or to manipulate the data. Let me pull it out for you. There is a table here called as localities that we will also work with. And if you look at the column headers or the fields of this, or attributes of this table, we got ID, we got area, we got city underscore ID, we got zone underscore ID. So if you notice, we also have area here, right? In the data table, we also had area. What was the area given there? Two types of area given, pickup area and the drop area. If you look at closely between these two tables, what is it? What are those columns which are common between this table? The localities table, which contains area, city information, zone information, and the data table that had data about each and every ride. Very simple question. What is the common column between the two tables? What do you guys think? So Arvind is saying pickup, area. Okay. How about others? All four, Sajal is saying all four are common columns between them. Not necessarily. See, Sajal, there is no column as ID here. And there is no column as city ID and zone ID in the data table. Komal is saying ID. In fact, Komal, this ID is not same as this booking underscore ID, Komal. This ID is an ID given to each locality. Whereas this booking ID is an ID identifier given to each ride. So then what are the common columns? If you notice, pickup area and drop area, right? These two columns actually contain areas. And the area is also given in the localities table under this column. Is it making sense, everybody? Does it make sense? Yeah, alrighty then. Now you will see, now you will tell me that, I thought, you were learning SQL, then why am I showing data in an Excel sheet? Well, this is not a very, very large data. At some point of time today, time permits, I'm going to show you what does it look, what is the meaning of a very, very big data, right? I mean, a data which could go into a few GBs, few terabytes as well, right? This is a relatively small data, a few thousand records here and there. Hence, I'm able to open it in Excel, all right? Because the focus is not to talk too much about large data, but to talk more about what SQL can do for you. Here, since the data is large, data is not that big, so we could have analyzed this data, manipulate this data from within Excel also, or from a similar tool like Excel. But if the data ran into millions of rows, imagine how many rides that people take in Ola every day. And if you're talking about 2-3 years worth of data, then it could easily result into huge data, right? So if you're working with very, very large data, that's when you will think of using structured query language, which is the language which databases speak, which databases speak. For example, you and I can understand each other because we are able, we are talking the same tongue, same language. SQL is the language which databases speak. And what is a database? Database is a collection of multiple tables. Database is a collection of multiple tables, right? Now, if I were to say database is a collection of multiple tables, then let's design it, let's put it as a cylinder, because that's the global icon for representing a database. Let's put it as a database. And within that database, we have multiple. What are these? These are table. And each table has columns and rows, as we just saw in the two examples that we looked into. In our case, we are working with, let's say, a database called as Ola database, and there is a table here called as data table, which contains all the ride information, and there is a table here called as localities, which contains some locality specific information, and there is a common column between them. All right. The common column is, in this case, is important because maybe we have some information that is only available in the localities table, and there are some information which is only available in the data table. And in some cases, to answer certain business questions, you may require information, data from multiple tables together. And that is when having a common column can be extremely useful. We will see that today as well. Alrighty. So, any question on what a database is and what the tables are and what the columns are and what the rows are? Any question on that? No? Great then. Now, this database, sorry, is a repository, is a software application, software tool, which is a collection of programs which allow you to create multiple, sorry, I'm talking about database management system, that is DBMS, is a collection of software tools or software programs which allow you to create databases, tables in the databases, columns, and rows in the databases, right? It also allows you to populate data or insert data, right? It also allows you to manipulate data, meaning change data, right? And finally, it allows you to query the data. Why this is so important for any data science person or any data analyst? Why is querying important? Because with querying, you can answer business questions. Hence, querying becomes extremely important for any data analyst to know. Today, the focus would be not so much about how do we create, because that's very easy. How do we populate? Again, because as a data analyst, you're not really populating the data. You will always get data dumps from from some kind of a data repositories or databases. But as an analyst, this is where your 90% of your time goes. And hence, we will focus a lot on the querying side so that as an analyst, we can answer business questions, right? A little bit of history about SQL. SQL was designed by computer engineers, IBM's two famous research scientists in the early 1970s. They designed SQL for non-computer science people. They designed SQL for business users because they were frustrated with all the business queries that they used to get from business users about the information that used to lie in computer systems back then. So they said that, all right, let's create a language which any non-technical person can also use in order to query and get answers which require data from data repositories or databases. So SQL, structured query language, was designed for non-technical folks, non-techies. Hence, it is very English friendly and easy to learn. And hence, this is so popular. Even though it is so old, yet it is so popular because it is so easy to work with, right? Now, with that understanding, let's look at a little bit more about SQL. SQL is used for inserting, extracting, manipulating data from a database, as we just saw. Why is it required? Common tool, language to work with data stored in multiple databases. It does not matter which software company had designed that database management system, whether it was Microsoft, Oracle, IBM, open source, free, not free. As long as it's a relational database management system, that means a database system which allows you to create multiple tables, you can use SQL irrespective of the company that the database has come from or the software, the database software that you're using. That is the main power of SQL, that if you know SQL, you can work with database systems by any database management company or any database software. Who uses SQL? Human beings use SQL. Like, for example, you and I, if we want to get some data from the databases, we will use SQL. Reporting tools like Excel, Power BI, Tableau, Python, R, they all interface, they all have SQL interface to fetch the data from databases. Remember, if the data lies in a database management system, then SQL is the only way to get the data out. Okay, hence SQL becomes so popular. It is accepted universally by different database management systems or tools or softwares by different companies. It's very easy to learn because, as I said, it was designed for non-techies, right? Now, there is something called as ANSI SQL, American National Standard Institution's recommended SQL language, which is the language which database companies use. Just like Merriam-Webster or Oxford in the UK, those are the authority in English language. When they publish, when they include a word in their dictionary, then that word becomes part of the English language, right? So anybody who's speaking English worldwide, they kind of follow that dictionary. Similarly, ANSI is that organization, not-for-profit organization, which decides the SQL language, syntaxes, protocols, commands, whatever you want to call it. And all these database management system companies follow them. So SQL statements are divided into three different parts: data definition language statements, which helps us to create and modify the databases, database designs, like create tables, create relationship within the tables, and so forth. And data manipulation language statements, which allow you to insert, update, delete, and select, which is query. So we will focus a lot on select part, which will help us, which will help us to query, because that's where 90% of your time goes. Something that we will not focus on is database control language statements used by database administrators to decide who has what level of access, and the IT admin stuff about the database. We'll not go into details about that. We'll focus mainly on SQL select statement, which allows us to query the data from the database management systems. All right. With that primer, with that preface, let's jump into analyzing data from these two tables: the data table, which contains the right information about Ola app, Ola rides, and the localities table, which contains some locality specific information about each one of the areas that the Ola cab went to or picked up or dropped the customers from. Now, if you remember, I said nowadays everybody uses databases on cloud. On cloud meaning a remote system somewhere in the internet that we do not know exactly in which physical location the database is getting created and the data is actually getting stored, right? So we will use something called as Google BigQuery, which is part of Google's cloud platform services. Google BigQuery, a tool designed by Google Cloud Platform or Google to work with large or to run SQL queries on extremely large data sets. Okay. And the best part about this is that for trial purposes, for free, you can actually work with a lot of data sets for free, up to 12 data sets for free. So that's what we will do today. Now, I am going to give you a link to download the data set and the queries that we'll be using in today's class to analyze the data from these two tables. Okay, now look at the chat window. I am going to give you the link. Give me a second. Look at the chat window, please, and go ahead and download these three files which are uploaded over here. There is a file called as data_v4.csv, localities.csv, and there is a text file, Ola Cabs Essentials BigQuery queries. Please go ahead and download these three files. And once you have downloaded, please do confirm on the chat window that you have downloaded these three files. All right. Now, once you have downloaded these files, right, then we will go into and guys, how do we download? If you're wondering how do we download, I've given a link in the chat window. So please look at the link in the chat window. And then when you open that link, you'll be able to see these three files. And then when you right click on this, any one of these files, then you will see a download option down below. That's how you download the file from Google Drive. Over here, download, go ahead and download all these three files already. Once you have downloaded these files, then what is the next thing that we'll do? So we'll of course load. So now here, if you notice, there are two files with an extension .csv. CSV basically means comma separated values file, comma separated values file. Which essentially is a common data file format that can be opened by almost any reporting tool, by almost any computer application, which can read and understand the data. Excel, Power BI, even you can open it in text with text editor as well. Here, the idea is that it's not a proprietary extension by Microsoft or by Oracle or by any software company. It is an industry-wide common file extension format, very, very commonly used to store the data so that you can open the data in any of these software applications where you want to do either data analysis or you want to store the data. That means you can open the CSV files in any databases or by any reporting tools like Excel, Power BI, Tableau. Alrighty. So when you open a once you have downloaded this file, if you open it in Excel in your local machine, it'll actually open like an Excel file. Yeah, everybody has downloaded it. Anybody facing any challenge in downloading the file? No. Everybody has downloaded. Great. Let me know if anybody is facing any problem. I will help you in downloading these files. Great. Now, where will we upload these files? As I said before, we will use Google's BigQuery platform. So what I want you to do is that just go to any, go to google.com or go to the browser and search for Google BigQuery Sandbox. Search for Google BigQuery Sandbox, press enter, and the first link that you will get on Google, not the first ad link, but the first link you will get which says quick start using Google Cloud Console or sorry, go to this one, query without a credit card, introducing BigQuery Sandbox. Go there, and here you will find get started on the left hand side. You essentially want to go to this button here. Okay, when you go there, okay guys, can you all confirm that you are able to do it? Now, I want a volunteer for just for 2-3 minutes. I want a volunteer to share their screen so that I can help you all how to load the data that you would have downloaded. So anybody who wants to volunteer who has already downloaded the CSV file that I told you to download, anybody who would like to volunteer and share the screen so that I can help you? All right, Divya, do you want to share your screen so that I can help you, Divya?
Sir, actually, I have joined the meet from my phone and I'm performing the
That's
thing.
fine. Somebody else who can share the screen? Sajal? All right, Shravan Kumar is sharing the screen. Thank you, Shravan. Shravan, can you also talk on the mic? Can you unmute and talk as well, Shravan?
Yeah, hello.
All right, great. Now I can hear you. All right, Shravan. So what I want you to do is, yeah, you have, I can see that you have gone to, so open this tab.
You can give control for you also.
Sorry?
I'm giving control.
No, you don't have to give me control.
Okay.
I will tell you what to do.
Okay.
Yeah, I don't want the control. Go there.
Okay.
Yeah. So now close this tab and then, let's go to the 0 step. Just search for Google BigQuery Sandbox again on Google. Just close this tab. Search for Google BigQuery. Google BigQuery Sandbox. Actually, Google BigQuery Sandbox, but that's fine. Just click on this. Now scroll down. Scroll up, sorry, scroll up.
Get started.
Yeah. Scroll up, scroll up, scroll up. Here. Now, the best part about this platform is that it doesn't require any credit card. All the other cloud platforms, even for to try, would require credit card, even though they may not charge you, but they will ask you for a credit card. Now, so just dismiss it. Sorry, did you close it? Sajal? Sorry, Shravan, you were sharing the screen. Now stop sharing it, is it?
Yes, I stop the sharing. Can you share it?
Yeah, please. All right, let's go back again. Google BigQuery. Yeah, there we go. Here you are. Now, the best part about this is when it says bill update, just click on dismiss here. Because we are using the sandbox environment, which is designed for people to just try. So you don't have to even put your credit card at all, nothing at all. It just requires a Gmail-based login. That's about it. Now, here, let me give you a little bit of structure about this, okay, what you're seeing. In Google BigQuery, what you can do is you can create your own data projects. And each project, you can have data sets. And what is the meaning of a data set? Data set is same as databases. Just Google BigQuery calls it as data set. And in these data sets, no, Ritik, it's just click on dismiss, Ritik. It won't charge you anything. You don't have to give any credit card details or anything. In this data set, we will actually create tables. Okay, so let's go over here on the top left hand side. Yeah, there. Click on new project. So what we are doing is we're creating a new project. See, it says 12 free projects remaining. So that's fine for us. That's enough for us. Give it a project name as Ola Cabs _ something that has to be unique. Ola Cabs. And then something that has to be unique. So maybe this is fine. That has to be globally unique, yeah, in this thing. Now click on create. Give different names, guys, okay? You can't give the same name as what Shravan did here. Now, what he has done is, he has created a new project, but now, yeah, just click on done. Now, here, once you've created it, just click on this thing here. Just bring your cursor here. Yeah, just pin it. Here, there was a pin option. Just bring your cursor. Yeah, here. Yeah, so that, when you pin it, the advantage is that next time also it will be right over here. Now click over here. There is nothing right now in this project, right? Because we have not created any data set. So we'll create a data set. So click on these 3 dots again. Click on create data set. In the dataset ID here, give a name. Let's call it as Ola Cabs without any space. Yeah. And the data location, just select the first one you get. Essentially, now we are deciding where we are physically storing. So we are physically storing in a data center somewhere in the US. So multiple regions in the United States, the first option. Ideally, should be, all right. So Rajdeep, in which step are you in? Rajdeep? Which step are you in? Create data set? Yeah, so just go to create data set. Yeah, go back. Yeah. in a create data set, we gave a data set ID here without any space, Razdi, and then we chose the data location. Okay, so essentially we are creating this data set under this project. We are saving it in this region, and do not select any table expiry. Just click on create data set now. Yeah, it may just take, Rajat, it may just take a couple of seconds for you to load that thing. At times it just takes a little bit of a few seconds only though. Now what we have done is, Shravan, we have created a project. This is the project. This is the data set, right?
Okay.
Rituja, in order to create a data set, you go to these three dots in the project that you've created, Rituja. And then there is a create data set. Yeah. Yeah. Now you don't have to create data set again because we have already created the data set. But this is also a blank data set that we have created. So what I want you to do is just click somewhere here outside. Yeah. Now click on these three dots under the data set that you just created. Now, what do you think is the next thing that we should do?
Open or open.
No.
Open.
We should click on create table. Now,
Into the
here
path.
it says create table from empty table. Now, Shravan, think for a moment. I have given you the two data files, right? I've given you data.csv and I've also given localities.csv. Those are the two tables that we want to upload over here. So,
okay, I didn't download it. Can I download it?
So you have not downloaded it? Go ahead and download them. Right click, download, and right click, localities also download. And query also downloaded. Okay. Now go back to BigQuery.
Cannot download this file right to third-party cookies or drive. Showing. Hello.
That is something that. Which one? I mean, were you not able to download any of the files? Can you open it in Chrome instead of opening it in Microsoft Edge?
Yeah. Okay.
Yeah, just copy that link and open it in Chrome. It'll be easier.
I downloaded it.
Yeah, great. Go back to BigQuery. Now here in the create table from empty table, instead of empty table, click on this drop down here. Go to upload.
Browse.
Select the file. Select localities. The first one, yeah. Open. See, it automatically understands the format. And dataset project destination is project, right? Dataset, right? Scroll down. Table. Now give table name as localities without any space. Give it in all small. Localities. Great. Native table is fine. Come down. Now it says schema. Schema is essentially what it means by this word schema is that what kind of data that each column in this table will contain. Whether it will contain numeric data, that means integer, whether it will contain string data, that is text, whether it will contain date data, yes, no data, binary, that is, and so on and so forth. So we will just go ahead and do something called as auto detect. So what Google BigQuery will do is that it'll open the file automatically internally and understand what kind of data each column contains and automatically create the schema, the structure of the table, right? Assign the data type essentially to each column properly. Now come down further. There is something called as advanced. Click on advanced here. Yeah. Scroll down. Scroll down. Now, I want everybody to come to that level, right? What we have done is that we are creating a table, and where it says empty table, go up once. Go up once more, up all the way. So upload, selected the file, CSV file in the destination. We wrote the table name, localities, come down. The schema, we selected auto detect. Come down. And in the advanced option, come down. Just for, it's not mandatory, but make the number of errors allowed to be 10, so that if there are some rows which, Rajat, sorry, Shravan, can you go up top again? Go up top once again. Yeah, where are you stuck, Rajat? Okay, select file. So select the file, browse to the downloaded file, and then table name. Come down. Now, come down. Here, number of errors allowed, just make it as 10, because if there are some minor error here and there, will be okay, because we are uploading thousands of rows. So 1 or 2 errors is fine. So just make it 10 here.
Make it 10, right?
Yeah. Okay. And field delimiter is comma. Header rows to skip. That means how many rows that we should skip loading from the top. So say 1, because the first row contains the headers, the attribute names, the field names. So write 1 here.
A number of errors
here. Header row to skip, because there is only one header row, right?
Yeah.
And then click on create table. Now what it is doing is that it is loading the data. And now you can see the localities table is created. Similarly, come back over here. And this time we will load the data table. So go to create table. Again.
Browse.
Here.
Okay. Upload.
Upload. Select the file.
Data.
This one. Come down.
Auto schema.
No, you forgot to give the name of the table.
What should I do?
Name of the
data.
table, right? Data. Yeah, come down. Auto detect. Come down. Advanced.
Errors.
10. Header row to skip is 1. Create table. Create. So if you now notice, we have created 2 tables. Just open it again. Yeah, close it and open. Now you have data table and localities table. Now, if you happen to click on any one of them, let's say click on data table. So if you click on data table, it will show you, it's coming up, or click on localities table here, localities tab. Yeah, if you notice, there is the schema, which will tell you the field names and the data type it contains. And if you notice, if you click on preview here, it shows you the preview of the data as well. So the preview of the data is as expected. Similarly, if you go to data, you will see the same thing. Okay, you can see the details and all of that. Now close these tabs. Now let's go to the data and let's write our first select statement. Click on this and then click on query. So we'll first query. I will write our first query. Now, here, if you notice, select something from, this is the project name, dot, this is the data set name, dot, this is the table name, right? So select certain set of columns from this project dot this data set or database dot this table. Take any question? All right. Okay. Now, here, then it says limit 1000. Essentially, what this means is that here, because we may be working on a very, very large data set as well. When you say limit 1000, you are limiting the output. That means the number of rows that you want to query from the table to only 1000 records. Okay, so this limits, this reduces the time to execute the query. At the same time, reduces the resource requirement to run a query and the time to execute the query. And just write a semicolon at the end. Write a semicolon at the end here, right? Now, yeah, write a semicolon at the end. Did you write a semicolon? Semicolon. Semicolon. Okay, let me show you. All right, you can stop sharing the screen now. Now, what we want to do is, up until this point, Shravan helped me. Yes, Rajdeep, the video will be available for the participants who have joined the session. What we will now do is, we will actually, I have given you guys a few queries, right? So, by the way, yeah, in my case, I've got multiple data sets, but I'm going to go to this one, this data set, and here I clicked on 3 dots, and then I clicked on query, and then it gave me select something from this project dot this data set dot this table under pair of ticks. This is not a single quote, by the way. This symbol that you're seeing here is a symbol before number 1 in your keyboard. If you notice number 1, before number 1 in your keyboard, if you see there is a symbol, there is a keystroke given, which is called as a tick. Okay, it's an interesting symbol, which is called as tick. Okay, just before number 1 in your keyboard. And here, the table name, the project name dot dataset name dot table limit to 1000, and then a semicolon. Now here, if I mention select asterisk or star, then what it means is, and let me put them into different lines so that you all can see it very nicely. Select from this data source. This is the number of records that we want, and these are the columns that we are selecting. If you mention select star, meaning you're interested to get all the columns, and then you select everything, right, up until the semicolon, and click on run. What it does is that it opens this project, this data set, and this table that we have mentioned, and then it selects a column for all those rows from this table. So if you notice, we've got these columns here, this data set here, the one that we just uploaded, right? And you can see the results. You can increase and decrease the size as well to see the result properly. Now, if you remember, I gave you one more file, a text file to download. Now, if you open that text file, you will see these scripts which are pre-written. I have pre-written them. I will copy all of them, Control C, and then I'll come to this editor, right, where I wrote this statement, delete it, and I will paste it very nicely. And then I will scroll all the way up. Okay, now in SQL in general, especially in BigQuery SQL by Google, when you put things under / asterisk, and then when you close the statement under * /, right, then this statement is considered to be comment, meaning plain English statement which will not be executed by Google BigQuery. So this is a good way to write some description, some notes as to why you're running that query, what are you going to do in that query, and so on and so forth. Now, the overall, today we will at least try to do one basic analysis using SQL, which is find the top 5 pick zones in terms of number of pickups, total number of pickups. Just I'm going to press Alt Tab and go to the table over here. You can see there are a lot of pickup areas, a lot of cab rides that are happening in different pickup areas. I want to find out though what are those top 5 pickup areas which had most number of pickups happening in this entire rights data rights table. Got it? That is the overall analysis that we want to do today using SQL. Now, for that, couple of other things that we will learn, other things that we will do. The first thing that we are doing here is that we want to find a distinct list of pickup areas, right? That is what we want to find in this query. So line number 8 and 9, look at this. Line number 9 says from, again, I've copied the project name. Now, in your case, the project name will change. So please go ahead and change the project name to whatever project name that you see over here. This is my project name. Your project name would be different. So project name dot dataset name, which is this, dot table name, which is this. Your project name and your table name could vary. Okay, so this is called as a dotted notation to give the data source, project, dataset, and table name. Limit 100 and semicolon. All SQL statements should end with a semicolon. That's how the system understands that this is the end of SQL statement. So, and then what are we selecting? What do we want? We want pickup area column, but we have also written something called as distinct, which will essentially give me the different pickup areas. Because remember, for example, airport terminal 1 and airport terminal 1 2 times, and again it appears multiple times because a pickup could happen from airport terminal 1 multiple times, right? But we are interested to get only the distinct list of pickup areas. So it's so easy to do this. So I select both these statements and I click on run button over here. It does its own magic. You can see it's running, and it ran and gave me the result. So I can see over here, these are the results. How many results are there? Maybe if I look at overall results, we'll find out how many distinct pickup areas are there. Okay. For that also we will run a query. If I don't limit it, then what will happen is it will show me the distinct list of all the pickup areas. So if I run this statement, it may just take a little extra time because we have not limited the number of outputs here. So we got 453 pickup areas. So these are the distinct pickup areas count. Got it? Now let's look at the second one. It says summarize total number of distinct drop areas. Here we found the pickup areas. Now here we are finding the drop areas. So from, again, the same table, limit 100, count. Here we have used a function called as count. Just like in Excel, you have sum, count, average function. Here also in SQL as well, we have a bunch of these functions which does its own magic and gives you the some kind of calculation in return. So we are counting distinct pickup areas. Well, in fact, I should have counted the drop area. So I'll select drop area, right? And I select this statement and I run it. And what it does is that it gives you 313. That is the total number of distinct drop areas. The total number of distinct pickup areas was how much? Anybody remembers? What are the total number of distinct pickup area that we got? Anybody who remembers it? When we ran this statement, 453. Thank you, Ritik, Praveen. Thank you. Now let's look at the next query, line number 15. It says, find the list of the distinct combination of driver number and drop area. Remember, a driver could drive this driver number. A driver could drive multiple times to a particular drop area. So that is why we are looking for the distinct combination of driver number and drop area. So distinct, this time I've written distinct, and then I've written two columns after select statement separated with a comma. So if you want to display multiple columns or extract multiple column information from a table using the select statement, then you separate them with a comma. Drop area, comma, driver number, driver underscore number from this table, again limited to 100 rows only. Now it ran and it gave us some results. Distinct combination of drop area and driver number. Now let's look at line number 19. It says list the drivers driving into each drop zone. So if you look at the ideal output that we are looking for, we want in one column driver number, then in the second column we want drop area. That is the data that we are looking for. Distinct list the driver numbers driving into each drop zones. Now it says drop zones, not area. I'm so sorry. It says drop zones. So zone information, if you notice, where is our zone information? Because if I look at the data table, it has area information, but it has no drop, it has no zone information. Where is the zone information? Anybody who can quickly tell me? The zone information is given in the localities table. So in order to get that zone information, we need to find the common rows between the localities table and the data table here. Since we are looking for drop zones, it said drop zones. Hence, the areas that are corresponding to, that are equal to the drop areas over here, right? And the zones corresponding to them would be the zones which are drop zones. But now we want data from more than one table. So how do we get the data from more than one table? That is where one very fine concept of SQL comes into the picture, which is called as joins. So if you notice in this query, what we are doing is, we after from statement, so far we had written only one table, but this time I have written this one table and separated with a comma another table. And what is this table? Same project, same data set, but localities table, again under pair or double ticks, right? So from these two tables, this statement, the moment after from, you write two tables separated with a comma, this ends up joining the two tables. Joining meaning horizontally joining the two tables, horizontally merging the two tables, which allows us column access to the multiple joined tables together. Right? Now, we are saying that we are joining these two tables on the basis of which two columns? On the basis of drop area is equals to area. That way, we can then get the zones which are corresponding to specifically drop area. Right? Again, we are limiting to 100 records only. This is considered as inner join or intersection join, which is commonly known as finding common rows between the two tables on the basis of a common column. What is a common column? Here we are assuming area from the localities table and drop area from the data underscore OLA table. All right. So this gives you, if you look at the result, this gives you zone ID and then the driver number going into each zone. Okay, and we have used distinct here because a driver could drive multiple times into a zone. Another way of writing inner join. Here, this is a more manual way of writing inner join. Another method of writing inner join is from this table, inner join. Here we had to use a comma. Here we have used a keyword called as inner space join this table on the basis of these two common columns. Drop area is equals to area. The only difference between the two is here we wrote from this table, comma, this table, where this area, this column is equal to this column. Here we have used from this table, inner join this table on the basis of this particular common columns. So when I run this statement, you will get the same result again. So either you can use the inner join clause like this command, or you can use simply comma and then write a where statement to equate the two. Now, you might have noticed SQL is not so case sensitive. So SQL is not so case sensitive. Now, let's look at this. 29th. How many times the drops were made in zone 27? Specifically, how many times the drops were made in zone 27? Now, zone 27 drops were made. Now, drop information is there in the data table because the drop area is there in the data table, and the zone information there is in the localities table. And hence, again, we will join these two tables. Whenever we need column access, information about two or more columns from multiple tables, we end up joining the two tables. So from this table, inner join localities table on the basis of drop area is equal to area, so that we can get the common rows on the basis of a drop area, group by zone ID, and then zone ID comma counter zone. Now here, what we have done is select the zone ID, and then we have used again count function on the zone as CNT. As CNT basically does what? Let's not do this because we have not discussed what that does. So if you notice here, if I run this statement, I get the result. If you notice zone ID, and then there is some weird column name that is coming, and it shows 126, 171. Essentially, this shows how many times a drop was made in a particular zone. But this column label that we can see here is not a great intuitive label. And that is what we will do with the help of an as here. As, so that means show the result of this count as, let's say, total drops. So what this as will do is, this is also called as creating a column alias, like a short name for a column. It gives you a logical name to the column. So it shows drop here, total drops now. All right. I know I have taken a few extra minutes, guys, but just be with me for a few extra minutes and we'll just wrap it up. Find the total number of pickups made in each zone. Total number of pickups made in each zone. Look at this now, interesting thing we are doing. Here we learned a concept called a zone, group by zone. Why did we group by zone? Because we wanted to find the total number of drops in each zone. Here also, we want to find the total number of pickups. So this time we are joining the two tables, but on the basis of pickup area. Here we had joined the two tables on the basis of drop area. Here we are joining the two tables on the basis of pickup area because we want to find the total number of pickups made in each zone. And then again, we are aggregating or grouping the data by zone because we want for every zone. So zone, and then we will discuss what this means little later. So I'm just going to cut it for now. Now, if you notice, select zone ID, comma count of pickup as number of pickups, limit 5. So we're just limiting 5. And if I don't even limit, sorry, let's not even limit here. Now this, so this will give me the total number of pickups made in each zone. Just like the first query give me the total number of drops made in each zone, this one gives me total number of pickup made in each zone. And the only difference between the two queries, this query and this query, is that here we had equated the two or found the join on the basis of drop area. Here we have equated or found a join between the two tables on the basis of pickup area because we want pickup. Now, the final question of the day, which is find the top 5 pickup zones as per the number of pickups. That means out of all these zones that we have gotten, there are so many zones that we can see, 39 zones. and the total number of pickups. We only want to show those zones where the total number of pickups is the top 5. I mean, the 5 highest number of pickups, right? So this is where we will need to sort the data. What will we sort the data by? Anybody? What will we have to sort the data by to get the 5 pickup zones which got the most number of pickups? So what will we sort the data by? So we will sort the data by the total number of pickups in which order? In decreasing order. Sort the data by the total number of pickups. That means this count of pickups by in this decreasing order. And after sorting it, then we will just get those top 5 rows, right? So 2 concepts that we will use here in order to do this query. So I'll just copy this query, Control C, come over here, Control V, and then here I'll simply write order the data, order by count of pickup area. Order by is to sort. Order by meaning sort by this column in DSC, meaning descending order, right? Now, when I do that, it gives me zone wise total number of pickups. You can see it's sorted in decreasing order by the total number of pickups. And then what is the final thing that we will do in this query, guys? We cannot, Sri, good question, Sri, but we cannot use the alias name for ordering, unfortunately, because of the execution sequence, Sri. Even though we write it select from, group by, order by, but the system reads it like this: from, then group, then order, and then select. So the select is the last thing that normally that gets executed, Sri. Now, what is the thing that we need to do here in order to only show the top 5 rows from this result, from the result of this query? That's right. So we'll limit it to 5, which automatically only shows the 5 top rows from any query. We have already used limit multiple times. So limit 5 and semicolon. That will finish our query. And now the output that we will see will be the top 5 pickup zones. I mean, the total number of top 5 pickup zones in terms of number of pickups. Great, guys. It was great having you today, guys. 2 questions I'm giving you, right? There are 2 questions given at the end. Find the top 2 drop areas as per the total number of fare collected, and find the top 2 drop zones with most number of cancellations. I will, I will give the answers to these questions. I will upload the recording of today's video on Ivy's YouTube platform. If you go to Ivy's YouTube platform, you will, I'll just give you the link to Ivy's YouTube platform. By tomorrow, this video should be uploaded over there, and feel free to get the answer to these 2 questions on the description of the video that will get uploaded. To these 2 questions. Great having you here. Remember, guys, you still have 2 more sessions lined up tomorrow and day after. Very interesting session tomorrow. You will have with Ishani. She's going to talk about data visualization on similar or same data set. And day after tomorrow, you will also do some machine learning using Python on similar data set for the same industry, cab aggregation industry, real life data set. And you will have a great experience with both the faculty members who are going to be coming tomorrow and day after. Both of them are quite experienced in their own domain. If you want to get connected with me socially, then if you search my name, Pratik Ivy, on Google, Pratik space Ivy, the first link that you will find will be a LinkedIn link, and that is my link. I'll be more than happy to get connected with you. Feel free to ask me anything about data science industry. I'll try and help as much as possible. And also, I'm pretty active on Twitter. I'll be more than happy to answer that as well. And get connected with you guys. Great having you guys here. I really wish that you guys practice on this platform. It's a nice platform, guys. And if you want to learn more, I'll be more than happy to answer all your queries. Thank you, guys. It was great having you in Cloud SQL. BigQuery session today, and I'll see you guys tomorrow and day after. Have a good one. Take care. Good night, everybody. Don't forget to get connected with me on LinkedIn. Just
Hello, sir. Pratik, sir.
yes, Ramesh.
Yeah, this is Ramesh. Actually, is this first session or actually
First
today is my
First session.
even I was not there for the beginning of 10-15 minutes.
So you can watch the recording, Ramesh. If you,
yeah.
yeah.
Okay, no problem. Yeah, thanks.
Thank you. But you got the files, right, Ramesh? All right. Yes,
So,
Divya. Yes, Dia.
Dia here. So, are you the regular tutor on Ivy for
Yeah.
SQL?
I am. I am
Okay,
the
sir. Thank
tutor
you.
for SQL module.
Okay, sir.
Ritik, on day after tomorrow's session, ask that faculty. He's great in GitHub.
Sir, actually, currently, I just want to ask about the Google Cloud basis, not as a Jupyter or any console-based project. Actually,
Right.
Google Cloud project basis it's facing up the difficulty to upload in the Google, in the GitHub. That's why I'm asking from your side.
Yeah. So just
we have
ask
to
this question.
we have to download all the data set and
Yeah.
queries, then we have to. So
Then
I
we have,
just has the Jupyter notebook, we can able to upload it in the GitHub.
yeah, but not from.
So it's possible from the Google Cloud base also.
No, it's not. Unfortunately.
Okay.
No, at least not that I am aware of. Ritik.
Okay. Okay, sir.
All right.
So,
Yeah.
so one more question. So, if I was supposed to take up one of the tools like Tableau or Power BI, which one would you?
Well, I mean, both are doing great, Dia. Power BI, we are hearing quite a bit nowadays, but Tableau also, I mean, it's like both are great, Dia. I mean, you will not go wrong with either one of them. But if I were to ask if you're okay learning a little extra, then I would say Power BI. Power BI has a little bit of data modeling and all of that, and being a Microsoft tool is getting a lot of popularity also, Dia.
Okay, sir. Thank you.
But do ask this question to Ishani tomorrow as well. She's an expert in both the tools.
Okay, sir. I'll ask her. Thank you.
Bye-bye. Good night, guys.